Merci beaucoup, and apologies for speaking in English. So I'm a senior research associate working at the Helen Hamlyn Centre for Design at the Royal College of Art. We're a sort of design research centre, and we work with companies, government agencies and charities on using always a kind of people-centred research and design methodology. So we're a little bit anthropologists and a little bit designers and maybe a little bit engineers. And today I'm going to present to you a project called Sightline, which it's all about trying to make streetworks and construction sites less disruptive for blind people. I think hopefully it's relevant to what we're talking about today because we can view blind people as a kind of extreme user case of people who are affected by streetworks. So if we create something that works for them, then hopefully we ought to be making something that's easier for everyone. And I'm going to start hopefully with, rather than my voice, the voice of some of the project participants, so a video about the project, hopefully.
On Monday when I walked out, there was roadworks right there. I didn't know what to do, so I just went home again.
I would say roadworks. That's the biggest problem on the street now, the roadworks.
If I was by myself, it would have been a different situation. I would have had it.
So we know I'm all right, and there's an arrow. Now that's pointing the other way, so that's showing me that the works are going back, and then we're out of it. We're done. I've got the directional arrows, and then I've got the heavy-duty markers, the dots. Yeah, I mean, I would certainly learn that very quickly. You know, ideally, obviously, you want the barriers all to be the same everywhere in the country.
I could definitely teach somebody to use this system in terms of mobility because you've got the tactile markings on there. They could trail with the back of their hand. I think it's so much easier to use than the first one we walked through. So given a choice of the two, this would definitely be my preference as a visually impaired person.
On Monday when I walked out, there was roadworks right there.
Can we have the PDF back?
I didn't know what to do, so I just went home again.
I would say roadworks.
Right. Sorry about that. Okay, so hopefully that gave you a bit of a flavour of what I was trying to do and what we've done. I'm going to tell you a bit about the process now. So the project actually grew out of another research project working for the UK government's advisor on architecture and looking at the design of public spaces in general for people with sight loss. And the research for that project basically involved shadowing 8 different people with different levels of visual impairment on journeys they'd regularly make unaccompanied, and videoing the whole thing and kind of seeing what happened really and asking people questions. And that worked really well because often people don't have the vocabulary to talk about the street, and so it's a lot easier when you're in the street and they're standing on something and then they're talking about it. And also people don't always do what they say they do. So it was quite a useful way of learning a lot, I guess. One of the outputs was these graphics that communicate the way that different participants were using different information sources at different spatial scales. So the idea is if you take a slice through at any of the points up the vertical axis, then you get the combination of information sources people were using. And what's striking about most of the participants was the extent to which they were using memory to navigate compared to sighted people, which I guess, if you think about it, is obvious. But and then because of that, that's why streetwork sites are so problematic, because they can completely wipe out someone's mental map of an area, even a relatively small disruption, and can leave someone totally disorientated. And then also in terms of the sort of biographies of people with sight loss who lose their independence, it's normally a couple of traumatic events that cause people to feel that they can't cope and they don't go out anymore. And these are disproportionately caused by disruptions like this, or things that aren't as people are expecting them to be. So unlike in New York, in the UK we do actually have a code of practice that's nationally mandated, that anyone that's doing any work that impacts the sort of public space has to obey. And at the front of it, it has this key question: will someone coming along the road or footway from any direction understand exactly what's happening and what's expected of them? And I guess it seemed from sort of the research that the equipment that we're currently using doesn't do that at the moment for people with sight loss. And actually this presented quite a good design brief for the project. So can we make the equipment work and do that for those people? And also, can we do that with the minimum number of changes to what we're currently doing? Because we were aware that for anything to be implemented, it had to be free or really, really cheap. So the first step in the research was to go and survey a whole load of streetwork sites. Did 100 in London. And this was basically to get a baseline on what people are doing and crucially what equipment was in circulation. Because again, the intention was to design a system that could be applied to all the equipment that was in use. I also went through all of the legislation and manuals that affect all of this stuff, because again, there was no point in proposing something that required legislative changes in order to happen. And then, as you'd expect, lots of shadowing of people with sight loss. This time, going through a series, we found a place where there was lots of streetworks going on, and we shadowed people through those sites and saw what tactics they were currently using to navigate, because the intention was to augment the kind of ways of working that people were already using. I also became a contractor. I did the training that the contractor personnel have to do in order to be allowed to operate on the carriageway, and I shadowed some of those personnel themselves working for the London Municipal Transit Authority to see their work practices. This was really important because there was no point in designing something that worked really well for the blind people, but then the guys that were expected to use it couldn't use it. So all that information was kind of synthesized into a first prototype of a system with sort of a whole load of different ideas, some of which worked and some of which didn't work. We tested that out with some helpful participants in the college and sort of got feedback, and also we circulated the design to sort of wider stakeholder groups to get more feedback, and then fed all that information into version 2 of the design. And this one, which is shown above, we did a sort of back-to-back trial of that on a real street in comparison to the current setup. So at the bottom, that is basically the sort of standard setup that we use in the UK. So I guess it is a bit different to what goes on here. So the system communicates on 3 levels to people, I guess, and this is probably, this first level is potentially the one that's most readily implementable here, I guess, because our equipment is slightly different. But basically, the reason it communicates on 3 levels is because blind people are a diverse group and they don't all want the same thing and they don't all have the same capabilities. So for people who have digital devices and are interested in using them, we provide a digital layer. And the digital layer is really good because you can provide information that's very complicated that you wouldn't be able to provide through tactile or visual coding. But then for people who don't want to use a digital device, we also provide high contrast visual information, and we do that because actually the majority of blind people have some light perception, and so you want to make the most of it. So provide very, very, very simple, very high contrast. So we've got a very clear indication of which side you're supposed to be on. The stripy red and white is not the side you as a pedestrian are supposed to be on, and the blue and yellow is the side you are supposed to be on. And then we provide effectively the same information tactilely for people that want to touch the equipment. So as part of the on-street test, we tested with 13 people. 11 preferred the modified setup and 2 registered no difference. So fairly encouraging from the small sample. Here's some sort of Photoshop of what the system would look like if it was implemented on some other kinds of equipment other than the plastic barriers, because the point was to design something that could work for everything that we're using. So this is the HERES fencing, which is very commonly used in the UK on larger sites. And then to come back to the digital part, which, as I said, I think is the bit that's most relevant. I think particularly with a project like St Catherine's, where you've got some very complicated disruptions going on that are changing constantly, being able to have really, really high quality real-time digital information about what's going on really helps everyone. And actually the people that are best placed to provide that information are the people that have just set up the equipment, because they know what they've just set up. So I think we want to get to a point where if you put out a physical sign or a bit of traffic management, like a barrier, you also create its digital equivalent at the same time. So we have this kind of prototype app that very, very quickly the contractors kind of tab through to just some simple checkboxes about the configuration of the site, how long they're going to be there, how long the site is. And then that's all saved in a geotag database. And then it can be retrieved by pedestrians in different ways. So for visually impaired people, we've currently got it retrieved through a near-field tag on the sign, but we're going to try and add Bluetooth beacons soon. And also being able to retrieve it with the GPS information means that you can find out when you're at home before you even leave what's going on, which is quite useful. The point I wanted to leave on, I guess, is these systems are quite easy to build, and the difficulty of persuading the contractors to use them or mandating the contractors to use them is much, much greater than the difficulty of actually creating the system. So there's a really strong argument that these systems should be public, and that you don't have to jump into bed with a big technology company and license an expensive bit of technology to do this. You can provide, the data that you're collecting about the infrastructure is what's valuable, not the system that carries it. So if you're going to do this, then build an open public system, please.